observation about the first question over here. The item A and B, 1A, 1A, B, consider the vorticity vector is equal to the curl of V. You see, this is a curl of vector V, or rotational of V. Now on the item 1A, only 1A, you use divergence of V is nabla dot V is equal 0. See, just to develop this. Don't forget to use this to solve A and B. Again, 1A and B, you see there's omega here and omega there. You see, just use omega is the nabla cross V. On this item over here, I'll just a hint, okay? You don't have to substitute, don't substitute omega by this. You just work directly on omega. You see, you don't substitute here. You just work directly on omega. Okay? Quiz question. Here I present 4 questions, quiz questions, for you to solve them. Now you see the answers of these quiz questions after you try to do these questions. These quiz questions, on the first question, don't forget the vorticity vector omega is equal rotational of V. That's a curl of V. Curl of V. Just to develop this. Now let's solve 1A. See, 1A. 1A. Now, Laplacian of vector V is equal minus the rotational of vorticity. So let's write this. Laplacian of V, I can write, you see, look, Laplacian is divergence of a gradient. See? Now, a gradient, if a scalar is a vector, a gradient of a vector, this is a second order tensor. It's a gradient of a vector. Divergence of second order tensor, this is a vector. See? This is first order or rank order tensor. Order or rank is the same. See? This is called also rank. Now let's do this. How I represent the left-hand side using Cartesian tensor notation. So this is a second derivative. I can write here second derivative of vector Vi with respect to xj. See? That's a Laplacian. Then I can write Vi, comma, jj. See? I want to prove that this is equal to the right-hand side. You see? This is the left-hand side. This is equal left-hand side. Now let's develop the right-hand side. So let's call the right-hand side is nabla cross, you see, omega is the rotational of V cross of V. See, let's see of this. Now, again, I call this the vector U. So, rotation of u, let's call rotation of u this epsilon I j k. Now attention now, partial derivative of x. You see this k, comes here and j comes there. Now this rotation, I'm sorry, this is, see, look, rotation of u is there. Now I want to calculate u, because u is equal, this is v. Okay? Now I can call this, instead of u, I can call omega, no problem. Okay? So u, you see, is omega, no problem. Then I substitute u by omega. So this I can write, this will be ur is equal, you have to pay attention here, because this will be epsilon r pq, you see. Now partial derivative, now is v. Okay, now you see q over here, this will be vq, and this will be xp. Now, as we did before, I want to plug u over here. Now here is ur, this is uk, so I put k over here, no problem. You see, this is k, this is k. You see, now I will substitute uk over here. I want to call this vector here as small v. I'll put v over here. This I call a small v. Small v. Just to write down, you see, this is a vector. Okay? Now it's a vector. So v, I want to express v. Now uk I put over there, so epsilon. You see this ijk, I move k once, twice. Epsilon k ij partial respect to xj. Now I'll substitute uk. So this will be epsilon k pq. You see, partial of vk with respect to xp. See? This is, you see, look at here. Okay, it's easy to see. Look, k and k, dummy. J and j, dummy. P and p is a dummy. Q and q, dummy. So this is I, is free. So that's I put here vi. You see, that's a free index. Now develop this. You see, epsilon k pq is constant, so I can put outside and develop epsilon k ij, epsilon k pq. Remember delta minus delta. Now apply to, see, look, second derivative of vk, you see, with respect to xj, xk. You see, there's a second derivative, you see, because this is constant. So now I can see from here, I combined with p, ip. Now j with q, Now I will combine with q. You see the second, the third one, so iq. Now the third one with the second one, jp. This is equal. Now I'll have two terms over here. Okay, let's first do this, apply to that. So I'll write down here second derivative of v, x, and x minus second derivative, partial derivative, x and x. See? Now, let's do this. Now, delta IP, you see? IP. Now, delta IP over here, I will have, I'm sorry, this is VQ, this is P over here. See, I just copy here from there, okay, to there. This is P, see? Now, delta IP, will be I, you see? Because P will be removed and then I put I. JK, you see? JK. Or I remove K here, or I remove J there. So this put J here and put J here, see? See how it's easy? Easy. This is second derivative. Let's put second derivative, x and x. This is V. Now, this over here, I'm sorry, this over here is the first one, okay? Let's put this. This over here, minus, now, let's write down partial derivative V, partial x, partial x. Now apply this one over there. See, this is equal. Now let's see how easy it is. See, delta IQ, okay? I substitute, put I over here. You see? Now, delta JP, I put, this is J, this is P, so I put J. You see how easy it is? Now, let's do as follows. Let's do as follows. This will be equal. Now, I can write here as partial with respect to xi. Now, partial of Vj with respect to xj minus, now here will be, let's see, partial, second derivative, we'll put j over here. Now, second derivative of Vi with respect to xj to xj. Now, this is equal. So, since we assume divergence of V is equal to 0, what is divergence of V? It's partial of Vj respect to xj is equal to 0. See, this is divergence of 0. So, this term over here, this will be 0. So, this is exactly the left-hand side. This is minus over here. So, you see, if we develop this over here, okay, the whole thing, this will be minus, you see, minus, minus. You see, this will be minus here. You see, we start from here. We didn't put minus here. So, then the right-hand side, the left-hand side is equal minus, you see, the rotation of omega is equal, you see, minus secondary of Vi respect to xj. See? So the left hand side is equal to the right hand side. Look, instead of substituting here, let's work with the vector, or the vorticity vector. Now, let's develop this over here. So this will be V cross omega. So don't forget, first of all, this term is a vector. So this is a vector. So we must have one free index. So before develop this term, we know that must appear, okay, in the Cartesian notation one free index, where this is a vector. Okay? This is a vector. Curl of a vector is a vector. Now let's work V cross W, this here. Okay? Now don't forget epsilon I j k. Now you see it's V cross W, so this will be Vj Wk. You see, Vj, you see the same one, J over here, will be the first vector, Vj and Wk. Now, you see, let's call VW, now, V cross W, let's call this as vector, let's call U, okay? Now, this here is UI, you see, V cross W, you see, the free index is I, so let's call I, JJ and KK. This is a vector U. Now, I want to find the cross product, the curl of U, using always different letters that we put there. So let's call here as a small v. Let's call it small v, okay? Because capital V is there. Now, V is equal epsilon, let's put R, PQ or PQR, doesn't matter. Now, here is derivative, you see? Now, this is U over here, okay? This is the rotation of U. Now, don't forget, Q comes here, and P comes there. You see, the free index here is R. So, now, I want to substitute UI over here. No problem. You see, I just erase here, put I, just erase here, put I. No problem. So I will substitute UI right here. So VR is equal epsilon. Now, this RPI is the same as I move once, move twice. I, RP. Partial respect to XP. Now I will plug UI right over here. So epsilon, IJK, VJ, WK. You see? This is UI. I just plug over here. Now, this is equal. Now, epsilon, I, RP. See? Now, I put this outside because it's constant. Epsilon, I, JK. Now, second derivative, in this case, no second derivative. XP of VJ WK. See? You see, the free index here is R. No problem. You see, because you see, I is dummy, P is dummy, J dummy, and K dummy. So this is VR. Okay? Now let's develop this, use the identity for delta. VR, now I always do this, delta, minus, delta. Now I write down here, partial respect derivative, partial derivative of XP, Vj, omega k. Now this is equal. Now you see, look, I and I, so Rj. Now the third one, Pk. Now I will exchange Rk, and then P J. You see, the second one, take the third one here. Now, the third one, combine with the second one, so it will be Pj. Pj. Now, this is equal. I advise you to do this. Partial x, don't put symbols now. VW minus partial of x VW. Now let's see. Now let's work this. We'll operate on that one. Look, RJ, this is V. So this will be VR. You see RJ. Now PQ. You see, this will be P. Right here. Now, here, in this case, now here, this will apply over here. So, RQ, you see, this is R. Now, PJ, this will be J, and this will be J. You see, look, PJ, this is P, put J. So, this will be VJ. You see? And this one is P, okay, because P is over here. So in this case, okay, RJ, I put P over there, this is P. Now let's see here what happened. So this R is a free index, so let's develop this derivative here. This is a product, so this will be VR is equal, no, capital VR, partial respect to xp of omega p, see, plus now omega p partial respect to xp of vr. Now minus, now this is partial respect to xj, so this will be vj partial of omega r respect to xj minus now omega r partial of Vj with respect to Xj. This is omega r, you see? Just look carefully. You see, R is free index. Look, R is free, P is dummy. R is free, P is dummy. R is free, J is dummy. R is free, J is dummy. So that's okay. That's a VR. See, that's a vector. Now let's interpret. So this is a vector V is equal. You see, look, VR, this is divergence of omega. You see? Now let's V. Why V? Because this is a VR. R is a free index. Now divergence of vector omega. You see divergence, this is divergence. See? Here is divergence. See? That's a scalar. A scalar vector is a vector. Now plus, here comes the pseudo vector. So this is vector omega dot the pseudo vector. You see? Apply, this is a VR. So you put right V over here. You see? Now you can see clearly that omega p partial respect to xp, you see, this is omega dot nabla. This is an operator. Now VR, you put V. Now minus here is the same as this. So the vector is omega, not VR. So this will be V dot the pseudo vector applied to omega. And over here it will be minus, you see the vector, you see the subscript here is R, so this is omega. Now divergence of V. Omega divergence of V. You see? Let's put here. Okay. Now you see over here 4 terms, and the answer, the identity, has only 3 terms. Some of this will be 0, you're going to see why. Okay, now let's compare. You see this term over here? You see this operator, omega dot, the pseudo vector applied to V. This operator here is right here. See, let's put a dot here and a dot here. Now, let's see, minus the vector omega divergence V. Now, minus, there's a dot over here, don't forget this, there's a dot here, you see? Minus vector omega, divergence of V, it's over here, so let's put this, and put a double dot there, this over here is double dot, okay, right here. And this one, you see, UB minus, okay, V dot nabla omega is this one here. Let's put this 3 over here, and this is right there. You see? And also, you have to pay attention for the minus sign. You see, this minus here, minus there. This is minus here, minus here. This is plus, and this is plus. See? Now, we have done this term over here. Only this here. You see, this is the divergence of a rotational of V. Why? You see, look, divergence of W, the vorticity is the rotational of V. That's a vector V. And we did this before. If you don't believe it, you do it. This will be is equal to 0. This is a scalar. You see, divergence of a vector is 0 scalar, but there is a V here, a vector. A vector V times 0 is a vector 0. So, V, you see V, okay, now, divergence of omega is equal vector 0, because this is 0. See? 0 times a vector is vector 0. So then we have the 3 terms there and 3 terms over here. It's proved. The answer of questions 2, 3, and 4, please, next video, next lecture.